So here's a very niche problem that has a fairly ingenious solution to it. So we have the integral here of the natural log of x divided by x. Now, obviously, you're tempted with integration by parts because this is the same as writing the integral of the natural log of x times 1 over x dx. And you can use integration by parts here. And that's how we're actually going to start this off. So, we'll start up our u dv, du v. So the u in this case would be the ln x, and the dv is 1 over x using late logarithms before algebra. Integrate or differentiating log x, we get 1 over x, and integrating 1 over x, we get log x. Looks a bit strange, but we'll keep going. So the way you do it is u times v. So I'll rewrite the whole thing. So the natural log of x over x is the same u times v. So the natural log of x all squared, which is written as ln squared x. ln squared x. Take away the integral of v times du, which is ln x over x dx. That might look slightly strange. We have the exact same integral here. So you might think this is an iterative process, and at some point we'll run into a bit of a wall. Or we'll run into a case where we're like, we don't need to integrate anymore. So again, we'll separate this. So ln x, 1 over x, 1 over x, ln x. So separating this, again, u times v. So the integral of ln x over x is now ln squared x take away u times v, so ln squared x minus the integral of ln x over x dx. So now we're just going to keep having this as ln squared x minus ln squared x minus ln squared x minus ln squared x, and so on and infinitely many times. However, we are just going to reach a point where the answer is negative infinity. So what did we do wrong? Well, we didn't put these in the wrong spots. It would not have been 1 over x squared times this integral, because that's not how the late rule works. We actually have to sort of go back to this stage right here. So at this stage, we've written the integral of ln x over x is ln squared x take away the integral of ln x over x dx. So the thing we can do is just add the integral of ln x over x dx to both sides. And with that, we get 2 lots of ln x over x. We get dx in here, so dx equals ln squared x. And then we just divide by 2. So we get natural log of x over x dx is just 1/2 ln squared x plus some constant c. And if you check it on any sort of integrating calculator, you will get this as the result. So this trick you can actually use in another integration by parts that I will do in a later video.